Alright, so for 2C notes, we're going to be solving and graphing absolute value inequalities. So let's just review an OR statement here that we had done previously on section 4.2b. Solving absolute value inequalities are basically an extension of compound inequalities. So yeah, let's just go through this one here. So first of all, on the blue, I'm just going to get rid of this and we'll just talk through each of them. So first of all, the blue equation inequality here. First thing we need to do is get rid of the 5. So we subtract 5 from both sides. When I bring down the x, take the negative with it. So negative x is greater than or equal to 9 minus 5 is 4. Then we need to get x by itself. We got to get rid of this negative sign. So we divide or multiply by a negative 1. 4 divided by negative 1 is negative 4. And again, I just divided by a negative 1 or multiply by a negative 1. Either way, you still switch the inequality. For the green one over here, again, we need to get rid of the number that doesn't have a variable. So get rid of the negative 4. And we do that by adding 4 to both sides. So left-hand side is just left with a 3x is greater than 8 plus 4 is 12. And our last step here, we divide both sides by 3. 3 divided by 3 is 1, so I have 1x is greater than 12 divided by 3 is 4. And there's what your graph should look like. We have x is less than or equal to negative 4, so I put my negative 4 on the left, positive 4 on the right. Negative 4 has a solid dot and shaded to the left. Positive 4 has an open dot, it's just greater than, so open circle, shaded to the right. Alright, so this is just something that you're going to have to memorize. You got to know these two things. That when you see a greater than symbol, whether it's greater than or equal to, doesn't matter. But either way, when you see a greater than, that's an or compound inequality. And when you see less than, that is a less than or less than equal to. That is an and compound inequality. Okay, so with a little bit of rewriting there just to kind of make it stand out a little bit, you know, just kind of change it up a little bit. It's just one of those little things that kind of helps you remember them. So greater than is an or, less than is an and we rewrite them as compound inequalities. Now this is only for absolute values. So let's go ahead and jump into one of these, or we're going to do 4 examples total. So, okay, so this is a greater than. Okay, so greater than, we're going to make a little note that a greater than inequality is going to change into an or compound inequality. Okay, so another thing you need to remember about your absolute values is that when we have an absolute value, like if we have the absolute value of some number is equal to 4, then that means x could be 4 or x could be negative 4, right? Because a negative, we talked about this when we did the when we did the systems of equations, not systems, I'm sorry, let me back up. We talked about this when we did our order of operations, how absolute values produce 2 answers, because if x is 4, the absolute value of 4 is 4. And when x is negative 4, the absolute value of negative 4 also gives us 4. So we have a couple different equations that we can set up here. So that's what we have to do that when we're doing this. So what we're going to do is one of them is always just recopying the inequality that you're given. So all I did was recopy it and I got rid of the absolute values. The second one, we connect it with an or, okay, because it was greater than, so that means it connects with an or. And we're going to recopy the stuff in the absolute values. We flip the inequality and make the other number negative. Okay, so right here is what's different. So you can see how this one is greater than or equal to 7. We just recopy it. But the other inequality, and again, it's because we have these absolute value bars that we do this. We flip the inequality and make that number negative. Okay, once we do that step, all we're left with is exactly what we had done in the previous section, section 4.2b. So we're going to solve this the exact same way. Okay, I'm just recopying this so I have it in a different color so I can refer to the blue inequality and the green inequality. So we started this one off with just a nice, easy, simple one-step inequality. So we need to go ahead and get the 8 over on the other side. That's a positive 8, so I'll do the opposite and subtract 8. So we're going to subtract 8 from both sides here in this blue inequality. 8 minus 8 is 0, so I'm left with b is greater than or equal to 7 minus 8 is negative 1. Okay, now that inequality is finished. Now we go over to the green inequality. We're going to do the same step, subtract 8 from both sides. But we end up with a different number here now because, first of all, 8 minus 8 is 0. That's gone. So we have b is less than or equal to negative 7 minus 8 is negative 15. All right, so let me come down here and grab this number line so we can go through and do this one here. So we're going to go ahead and put the smaller number on the left, so that's my negative 15. Put the bigger number on the right, that's my negative 1. And now we're ready to graph. So graph them individually. B is greater than or equal to negative 1 means filled in circle at negative 1. Okay? Greater than or equal to means shade to the right. Greater than means shade to the right. The or equal to part right here means fill in your dot. B is less than or equal to negative 15 means, again, solid dot at 15, so fill that in. And shade to the left because it's less than or equal to. Okay, so again, this is just something that you have to remember when we're dealing with absolute values. If you see a greater than or equal to, that's an or. And if we see a less than or equal to, that's an and. So, I mean, more practice, it'll be easier for you to know, but it's just something you're going to have to remember. All right, one more that I'll do with you, and the other two I already have done. I'll just talk you through them. So, again, one of your inequalities is always just recopying your inequality without the absolute value bars. The other one is 3y minus 9. We flip the inequality. I forgot to change my color again. Let me back up. Change this to green. So we're going to say 3y minus 9. Flip the inequality. So now this will be greater than. And make the other number a negative. So negative 27. Now what do we connect this with? Well, this is a less than. So less than means and. Okay, so remember, when you have an and inequality, the way that I like to set this up is like this. Negative 27 is less than 3y minus 9 is less than 27. Okay, so I'm going to solve it like that because it makes less work. Okay, so you can do this whenever you have an and inequality only. Okay, you can only do it when it's an and. Put the smaller number on the left, less than or equal to. This stuff here, 3y minus 9, that's just going in the middle, and then the bigger number on the right. Alright, so let's go through and solve this one, and again, doing it this way makes it easier, fewer steps. So add 9, and again, we're going to add 9 to all three pieces here. Okay, if this is confusing to you, you can just keep continuing using these right here and just solve them separately. That's perfectly fine. If you want to do that, you can. Okay, you don't have to do it the way I'm doing it here. They'll both give you the same answer. Just make sure you're showing your work and you're good. So this is negative 18 is less than 3y is less than 27 plus 9 is 36. Now we're going to divide by 3, and again, divide all three parts by 3. We got a negative 6 is less than y is less than 12. Alright, so there's the problem done. Now let's put this on the graph. So I'm going to go ahead and move this up here. So put my smaller number on the left, that's a negative 6. Bigger number on the right, that's a 12. Again, these, I don't know if I said it in the last problem, but these inequalities will always match. So if one is open, the other is open. If one's a filled in closed circle, the other one's a filled in closed circle. And because this was an and inequality, means we're shading in between. Alright, the last two problems, I will talk you through them, but again, I already have them done here, so I will just talk you through them. Now, this is a less than, so that means I'm going to do my string inequality. So my left-hand side will be negative 18 is less than or equal to. The middle stuff is 6y plus 6, no absolute values, less than or equal to 18. Okay, so if we just kind of cover this part up, you can see it's the same thing we started with. We're just adding this extra part. Now, this only works for less than, because that's your and inequalities. Okay? Now we're going to go through our different steps here. We want to get y by itself. So move this 6 first. That's a positive 6. So we're going to do the opposite and subtract 6 from all three parts. So minus 6, minus 6, minus 6. And again, we end up with 6 minus 6 in the middle here. So that is 0. Okay, so then the left-hand side, negative 18 minus 6 is negative 24. Right-hand side, 18 minus 6 is 12. And then the last thing we need to do is divide all three parts by 6 to get the y by itself. So negative 24 divided by 6 gives us negative 4. 12 divided by 6 is 2. And now we're ready to graph this. So we're going to go ahead, put our smaller number on the left, that's negative 4. Bigger number on the right, that's 2. It's an and inequality, a string inequality, so we just shade in between. Alright, last problem here. Again, I have this one done for you, and I wanted to show you that usually when you're doing these types of problems, we don't always have it that they come out to be nice whole numbers and integers, so sometimes we do end up with decimals and stuff like that, so you know, it's okay, don't worry about it, just graph them. So let's first of all start off, this is a greater than, which means we have to connect it with or. So if it's a greater than symbol for your absolute values, you don't have that option of doing the string inequalities like this, okay? That's only when it's less than. So greater than means, again, drop the absolute value bars, so 4 minus 3w is greater than or equal to 8. So same thing, just without the absolute value bars. And then or, we have 4 minus 3w. Flip the inequality to make it less than or equal to, and make this number negative, so it's a negative 8. So now we go through and solve them. And again, one of the nice things about these absolute value inequalities is your steps will always be the same. So I'm getting rid of the 4 first. So I'm going to subtract 4 from everything. So minus 4, minus 4. Over here, same thing, minus 4 and minus 4. So I'm left with, bring down the negative 3w is greater than or equal to 8 minus 4 is 4. Over here, brought down to negative 3w is less than or equal to negative 8 minus 4 now is a negative 12. So even though we're doing the same steps, we're getting different numbers because these numbers on the outside are different. So now the final step is to divide by negative 3. And again, I made my little notes here that I have to flip the inequality. Alright, so let's just reveal the whole thing here now. So negative 3 divided by negative 3 is 1. So I have 1w. I flip the inequality. 4 divided by negative 3 is, you could leave it as negative 4/3. Or you can write negative 1 1/3. Just don't write it as a decimal because the decimal will not be exact. It will be an approximation. And we just want to leave it like that. Over here, divide by negative 3. Negative 12 divided by negative 3 is a positive 4. And again, I flip my inequality. So all you need to do when you see these type of inequalities, again, we're going to do the same thing. We're going to put smaller number on the left. So I'm going to come over here and put my negative 1 1/3. Put my bigger number on the right, that's a 4. And then we're going to do our circle. So these are both filled in closed circles, okay, because they both have this lined underneath it here. So since they both have that line underneath it, we can fill them in. To fill them in, w is less than or equal to negative 1/3. I should have done this in my separate colors here. Let's do that. Let's change this to blue. Since that's less than or equal to negative 1/3, we shade to the left. This one over here, w is greater than or equal to 4. Again, solid circle at 4, and then shaded to the right. Okay, so the absolute value inequalities are really not that much different from the compound inequalities. The only difference is you have to set up the inequality, okay? It's not set up for you. So, and again, really, it just goes back to that very first slide of notes after we did the bell ringer. Just knowing that greater than or equal to gives you an or compound inequality. And when we have less than or equal to, that's an and inequality, which you can just write as a string like that. Okay, so like always, if you have any questions, send me an email or a private comment and I will answer them. So if you have any questions, just let me know.